Welcome back. Problem 3. In the problem 3, is in the description, we says for the concrete gravity wall shown in this picture, we need to find the magnitude, direction, and angle of the resultant force, right? And determine where the resultant intersect with the base of the wall with respect to point A, right? So we have to use A for the summation of moment. Okay, so we need to find the resultant force. A resultant force has two components, Rx and Ry. We need to do that. Rx, we have only one force in x direction, Fx summation, and that is minus 50. 50 this one. That is the only x forces, right? And it's going to the left, so it's going to be negative, and that is this one. How about the next one, Ry? Ry is, we have two forces, both of them are negative. Um, this one and this one, 150 and 100. That gives you minus 250 kN. Okay, so we got two component. Remember, we have to find the magnitude of the resultant, square root of these two forces, Rx plus Ry. So you plug them in there. Once you do it, you should get this number. Okay, so that is the first step. So you can highlight it, you can show that is the result, the first result. The next result that we need to find is angle, right? What is the angle of that force? As you see, both forces are negative. My Rx is negative. This one is going this direction. My Ry is going this way. Um, so, what was the Ry? Oh, okay, 250. So both of them are negative, right? So in order to find the angle, remember we use this equation, arctangent or inverse tangent of Ry divided by Rx. So this is Rx, right? Rx. This is Ry. And this is my angle. Also, here Ry. We can bring it here. So what do we have? If you plug those numbers here, theta, you will have 250 divided by 50. That gives you 78 degree. So this angle theta is 78 degree. And then next step is to find the summation of a moment about point A, right? Let me transfer this one a little further down so we have enough space. Summation of forces about summation of a moment about point A. What do we have? We have three forces. One, 100, 150, 150 minus, one, this 50. 100, as you see, let's use 100 first. As you see, 100 has the distance we need for the moment. We need F times D. We have 100, right? That is F. What is the D? D is you have to draw the line of action. This is my perpendicular distance. I need to find this part. How much is it? As you see, the from here, this one is 2.5. Then I can subtract 1 meter, because in the top it's given 1 meter from it, so it's going to be 1.5. And then I have this portion half meter. So if I subtract these two amount, that gives me this portion will be 1. Okay, so 1. So let's do it. And it's making, you know, clockwise. So the clockwise, it's going to be negative moments. 100 force times, 1. So that's going to be the first force. How about the next force? Next force is this one. 150. Line of action, you need to find this distance. How much is it? As you see here, 2.5 is the total, and then you have this 0.5. So you subtract that one from 2.5. That is going to be 2. So 150 times 2. And again, that force is making clockwise rotation. What else? We have one more thing here. 50 is going this direction. That is going to be counterclockwise. It's going to make positive rotation. And what is the distance? The line of action is this one, right? So my shortest distance or perpendicular distance is this much, which is given 1 meter. So 50 plus 50 times 1 meter. So that is all moment I have. When you add them up, it's gonna be 350 K N M. Okay. The next one is X bar. Find a summation of moment about point A divided by R Y. We have all of them. We just put this number in there. RY was minus 250. That gives you 1.5 meter, right? So that means the R has an angle of 78 degree, right? So this also is going to be 78 degree, and it will have a distance with respect to point A 1.4 because it's positive. So it's gonna go through this point 1 meter away from point A.